Hello, everyone, and welcome to the GeekNarrator podcast. I am your host, Kaivalya Apte, and I'm back with another very interesting episode. Today, I am joined by Glauber Costa, founder and CEO at TursoDB. And of course, we are going to talk about TursoDB, its internals, use cases, architecture, and everything around it. So, thanks a lot, Glauber, for joining me today. I'm really excited to have
Thank
you.
you. It's my pleasure. Thank you so much for having me.
Awesome. Let's start with a little bit of introduction about yourself, about a bit about your background, and how did you end up building Turso.
Awesome. My background is in systems programming in general. I got started around the year 2003 in the Linux kernel. Initially, just through open source contributions. I was still in university and I took a liking. I always like to understand how things work at the deepest levels. And at the time, I was a really big fan of the back then we call it mostly free software movement, but then the wording open source ended up winning. And Linux was in the intersection of those things. So Linux was this open source thing and I still remember the first time that I just opened one of the source files of the Linux kernel. I understood nothing because I didn't read C and also was pretty young. In fact, it was a header file. It was not even one of the C files, but I was just looking at it and said, "Man, I can read the code of this thing that's powering my computer," and I was very excited about that. So I really liked it, and I took a liking. I started contributing to the Linux kernel around 2004. I joined Red Hat and worked there for a couple of years. And then later, I ended up joining a startup that was created by somebody at that was at the time at Red Hat. So Red Hat acquired their company, and they created something called the KVM hypervisor. So the older folks may remember that, which is usually what powers Amazon and other providers today for virtualization. So I worked in the KVM hypervisor for a long time. That was my main block of contributions to Linux while at Red Hat. And when the KVM folks left to create a startup, I joined them. And initially, this startup was also a OS startup. We were writing something called a unikernel. So I've done that for around 2 years. Unikernel is essentially a kernel that runs it's a dedicated kernel. It's not Linux that runs a single process. And there are some advantages of doing that. We didn't succeed with that. So the idea didn't really have a lot of legs. There is, by the way, a project that I want to call out called Unicraft that is doing this today very successfully. And I believe the difference is mostly times are different and the industry is different today. But and bit as it may, like we ended up pivoting away from that idea after 2 years because it didn't really work into a database company called Scylla. Scylla was my first foray into databases. I was joking about that with Dax, the Twitter guy, the other day on his podcast. He told me that his career was a little bit unorthodox because he learned NoSQL before he learned SQL. I said, look at me then. My career was way more unorthodox because I wrote a NoSQL database before I even learned any of them. So I did not know, and I'm still not the most competent person in the world in when it comes to databases, but I really know the internals, right? So but if you ask me to write a complex SQL query, last year I could not. This year I can. I've been doing this, but it's all ChatGPT. Don't tell anybody. But so that in terms of background, I was never much of a job hopper, so I've done those two things in my life. I've done 10 years, almost 10 years in the Linux kernel, around 8 years at Scylla as well. And then here we are at Turso. Pekka has been with me with this journey, by the way. Pekka is my co-founder, and we met in Linux. And I joined Scylla. That had a different name back then, but we joined the company that became Scylla. I was employee number 3. Pekka was employee number 4. So we've been together for a long, long time. And when it was time for us to finally found the startup, I want to do it together. So here we are.
Awesome. I heard about that. That's quite an amazing background in systems programming, by the way. And I heard about KVM and Unicraft when I did an episode on ScyllaDB.
Mhm.
and that was quite very interesting for me to understand how it works internally and why it is faster and high performant, better than Cassandra in that sense. And I I am still curious to understand why TursoDB and what was the
Mhm.
problem you were trying to solve, and why SQLite in that sense.
Yeah. So I think what I'm supposed to do is tell you this beautiful, well put together story about how one day I was sitting in the park and had this amazing idea of the thing that the world needed. But I'm a terrible liar, so I'm not going to do that because that's not how it happened. Turso was an accident, much like my third daughter. So and both are very welcome and very loved. But not always things. No, not always the good things are planned. Um, and it's funny because Pekka and I, we've been through this very traumatic experience at Scylla, and that is the experience that I just brushed over very quickly. But the pivot from a unikernel to a database.
Yeah.
Companies pivot, and that's fine. I think many startups have done this before, but it was very traumatic for us because we put 2 years of our lives into this project. It was not a pivot like after 2 months because, look, in systems programming, things take a long time. Like if you decide, for example, to write a new kernel today, if that is your idea, you don't really know if it's going to work or not until 2 years, because that's the time it takes to actually bootstrap the thing out of the ground. So we spent a lot of time, and it felt to us, although I'm probably being unfair to the Scylla folks, because especially today as founders, not everything that happens in a company gets propagated to the employees, and nor should it. But the impression that we had seeing that failure is that like they didn't do a lot of validation and asking right to the market, does the market need this? And so
Yeah.
when we founded the company, and by the way, like as I said, just another piece of important contextual information. I never liked databases. It's not that I hated databases, but I just didn't have any interest in databases. And it felt to me like why just doesn't attract me. I was very much attracted to like network storage and things like that. So when we started Turso, at the time the company had a different name. We said, look, we're going to do everything differently. We're going to validate aggressively. So for the first 2 months, we haven't written any code. We just like talk to people, and we're going to understand if the product that we're putting in the market is a product that people want, because we're not going to go through that pivot again. We know better. We better. We're not. And fate wanted that we would end up in the same place. So we've done everything differently, but we ended up with the same results to a uncanny level, because not only we had to pivot because the product that we had before was doing okay, but we were already starting to have concerns about, is this venture scale? And once you take venture money, some things that could have been a success become a failure because they don't achieve enough traction to justify the millions of dollars that the VCs are putting on you. So we were starting to have after 1 year. So first of all, 1 year, we did not want to build something for 2 years again, just to pivot out. So after the first year, this thing was not a hockey stick. It was okay. It was growing in users. It was getting new users, but it did not look like a hockey stick. And we were having some concerns. We were thinking, hey, is this the thing that we should be doing? And this is context. And in that product, we were using SQLite. So we were users of SQLite in that product, and we love SQLite. We loved it back then. We still love it today. But we were growing frustrated with the fact that we actually wanted to make some changes to SQLite. SQLite was the almost perfect database for what we wanted to do, but it wasn't perfect. I mean, there were some things that were like, if I only could do this and that. And then you have two people again with large experience in C and in systems programming and in databases. We felt more than capable to make those changes. And uh, but SQLite is a project that is in their own if you go to their website in their own words, you're going to see open source but not open contribution. They just don't take your code. They're not interested. And one of the things they say is that if you send me a contribution, if we like it, we may rewrite your contribution to do the same. But we not usually we don't care, which is fine. I mean, and I want to make it clear that they have all the right in the world to do it, and it's totally fine. But usually in open source, we hear if you're not happy, the beauty of open source is that if you're not happy with the way a project is managed, you can just fork it. And that's what we did. And we launched a fork of SQLite called libSQL. And when we launched that fork, I think it was October 2022, Chisel Strike, the company, had been going on for a year, around a year. And the project on GitHub, Chisel Strike, had around 1,000 GitHub stars, which again, after a year, is nothing. It's not terrible, right? But that's exactly what I was trying to convey. But it wasn't a hockey stick either. I mean, it was very linear, and you could really see that every time we push, we do some blogging and we do some writing, it goes up a little bit, but otherwise linear. And when we published the libSQL manifesto, saying, hey, this is what we want to do with SQLite. And by the way, we didn't write a single line of code. We were accused back then of all sorts of things because it's the internet after all. So you always get some hate, which is get part of the process. Who are those clowns? I mean, there's talking a big talk, but where's the code? And I don't trust them. And then some people who knew us saying, oh, well, I know those guys, you should trust them. But we just announced it without any code. No joke. Just saying, hey, we wanna have a community. We don't know yet. Here's a couple of ideas of what we could do, but we don't know yet what we want to do. But we know that we want to make changes to SQLite, and we know that we want to have a community in which people come together to build a database like SQLite that plays the same role of SQLite, but can take, is comfortable taking a couple of steps out of the core comfort zone of what SQLite is. And that got 1,500 GitHub stars in 2 weeks, right? Which is more than our project had after 1 year. And then you paired this with the fact, as I mentioned, that we were starting to see doubts in ourselves, which our investors didn't share, by the way. Our investors were all about, no, this is doing okay. I mean, you're okay for your stage. Just put more effort. Just do this. Just do that. But we had on our hands essentially this project that was okay, and this other thing that we just announced that was going viral, right? And then we let one of the things we've done is that we let the dust settle a little bit because this is a big decision. Do I just go all in on this or not? So we didn't want to just act on the moment. So we waited maybe a month or so for the dust to settle. But it seemed real. We had a Discord. We didn't have anybody adopting this because why would you, think about it? Why would you adopt it? It's the same code as SQLite. It's just but we had a community of folks showing support. We had a Discord community that people would join and say, hey, I love this. And those are the things that frustrate me about SQLite and that I would like to see. Schema changes was one that people kept complaining about. And we then decided to, hey, let's just go all in on it. And then we wrote the private beta for what Turso is today, because Turso is essentially a managed version of what we've done for libSQL, which is our fork of SQLite, right? So we wrote the private beta of what we wanted Turso to become in a couple of months, essentially 2.5 months. We put it out there. We got 500 people to sign up for the private beta. So, okay, yet another sign. And at the time we launched the private beta, we were still not fully committed. We still had people in the company working for the previous projects, because if this thing flops, then whatever, we go back. But the private beta went extremely well because we got 500 people to sign up. Not all of them created databases, of course, as usual, but some of them did. And we were in a situation where with a couple of months of work, we had more users than we had in our previous project. So it felt obvious to us that that's what we wanted to do. And then I look at Pekka and say, Pekka, we promised ourselves that, and I skipped through this, but when we started the company, we said, look, let's do anything in the world except another database company. There are too many databases. This is terrible. This is boring. Why would any sane person do it? I was already not a fan of the Scylla pivot because I did not want to write a database. And then after we wrote one, I did not want to write another database. But sometimes it feels like we're not in control of those things, man. And the things just happen to you, and you do have to make the choice. But the best rational choice at the moment was to do it, and we're good at it, and let's do it. But it was not my intention. It was not Becca's intention. Our intention was the opposite of that. Was just like a stay away from databases. But here we are.
Yeah. Well, that's an amazing journey. I mean, in a way, you felt some pain, and then you gathered feedback, and then you built on top of it, and
Yeah,
now here we are. It's a database. So I guess every person who has built a database might have said that we don't need another database, but
yeah.
there are so many databases, probably thousands by this time, that there is a database of databases, right? So um, it's very interesting to know. Um, well, you
However,
mentioned some of
however, I
the.
wanna clarify that sometimes people an operating system has the same problem for what it's worth.
Mhm.
Uh, because for us, for example, the operating system was always the kernel, and
Yeah.
you can still think about, yes, the kernel plus the, if you are want to use a more liberal definition, which is fine, it's the kernel plus the set of utilities that go around the kernel.
Mhm.
But then what happened, for example, is that people started creating like essentially skins, transforming just the visual appearance of something, or like putting and then call it a different OS. Like lots of those were based on Ubuntu or Debian back
Yeah.
then. Ubuntu itself, although Ubuntu did acquire enough muscle to say it is a different thing than Debian, but a lot of those OSs were really just like a very minor variants from the base. And the same thing happens in the database world. When you go look at those thousands of databases, a lot of them are just Postgres plus something,
Yeah.
or MySQL plus something. There are very few databases, if we want to use the term
Mm.
strictly. Not even if you don't go all the way to incredibly strict, even like there are not thousands of databases. That's my point.
Yeah, I think that's a valid point, and it's a good distinction as well. Like some of them are extensions, some of them are just
Yeah,
wrapper over some of the
exactly.
databases. Some are really written like from scratch, like end to
Yeah.
end, so they have full end to end control. So that's a good distinction. You while you were explaining your journey into creating TursoDB, you also explained some of the limitations that people faced and you yourself faced with SQLite. I mean, SQLite is great, but probably it is not meant for the mission critical applications deployed on production. And that's, I was also reading a bit on your website. It says SQLite for production, and some of
Yeah.
the testimonials that are there, they talk about mission critical applications and replication for their user data across the world and so on. But what are the key problems that you started hearing about SQLite in the very initial phase?
I think it depends a lot on what people imply and mean by the word production.
Yeah.
And I will explain just what we don't mean, and then what we do mean, because we don't mean to imply ever that SQLite is a database that you cannot trust with your data, which is what some people mean by production. SQLite runs in airplanes, right?
Yeah.
And it's an incredibly well trusted database. Now, could it be better? I don't know. And it was written 20 years ago. Like, can you write a database that is as trusted as SQLite today? Maybe with modern techniques, with deterministic simulation, things like that. Maybe, right? Just is it the best it will ever be? I do not know. But when we forked SQLite, our idea was not ever, and when we say SQLite for production, our idea is never to say, like, we're going to fix bugs on SQLite that make it crash and make it production ready so it doesn't eat your data.
Hmm.
And that's a very important distinction because, for example, when I was at Red Hat, and your audience is probably young, as most people, what happens with people like us as we age is that everybody else is young. And then we have those stories that nobody understands because it just didn't live true. But Linux at the time was complete chaos. So Linux was this thing that it was fully open source in a way that very few things are open source, especially today. But back then, just because there were fewer open source projects, And like there was code coming from everywhere, and like you would just download this thing from the internet, and whatever happens, and just still there was a lot of traction and a lot of interest from companies to use this, but the code itself was terrible. It had a good foundation, but it didn't have like any enterprise level processes to guarantee that the quality of the code is good. So initially, this changed over time, but the business model that made Red Hat successful was essentially, we're going to get this thing that changes every day and releases like a version every week, which was essentially the case. And like those spec, even if you don't count just the kernel, but also the packages around it, like there were versions coming out as we have today, like in the desktop. I mean, you do apt-get install or even brew, or if you're on a Mac, and like all your packages upgrade. And like this is just not the way enterprise runs software. And there's a bunch of bugs. So a lot of my work at Red Hat as the junior guy that I was exactly this. I mean, I will be given a list of bugs with KVM and other things. Go fix them, because those are bugs that and Red Hat would release a new version of Red Hat Enterprise Linux every 3 years, sometimes more. And this is exactly like this. Today we are freezing this version. We are freezing what the product is going to be. Now the customers start testing, and the customers are like banks and government agencies and etc. They're very and you find all the bugs, and you fix as much of those bugs you think, and then Red Hat essentially supports that and comes with a stamp that this is production ready. And I want to make the distinction that that's not what we're doing with SQLite. In fact, SQLite doesn't change that much, and it's very small, and people already trust it. So when we say this is SQLite for production, that's not what we're saying. What we're saying is that when you are running SQLite in production in a web-facing application, not in an airplane, on a toaster, on a clock or a watch, or those things that SQLite usually runs very well on, there are many things that you need to do to actually be able to use this as your production database. And that's what we mean. So some of those things, and this is the change that we wanted to make in our first product, and that's what led us. So I'm not saying this is more important than others, but just historically, that is what led us in this path. Replication, right? So you want to run a production database. You usually want replicas for one reason or another. And just SQLite, there is not a good way to do it. Like there were a couple of projects trying to do it. We that's actually one of the things that led us to fork it, because we saw a bunch of projects that were trying to do something to make SQLite a replicated database, but they all operated under the assumption that SQLite cannot be changed. And then they would do things, and again, I'm not criticizing them per se. They're good ideas, given the constraints. One example is LightFS from Ben Johnson, which is a person that I respect tremendously. But the idea of LightFS is exactly this. You can't change SQLite, so you intercept the writes that it does to the file system and distribute them around at the file system level. But that's not what we wanted to do, because now to deploy this, you can't really deploy this without a lot of infrastructure that companies are deploying. And we wanted to keep this nature of like, this is something super simple that we just ship and it's working. So we worked on SQLite native replication. That's one of the things. The other things that you want to do is having backups. Like you think it's easy to have backups of SQLite because it's just a file. Turns out it isn't, because you're not going to be copying a 300 gigabyte file every time, or you don't want to do this. You want to do incremental backups as you do with other database, and then you have things like horizontal scalability and things like that. Turso also add a lot of features and functionality to things that are patterns that the SQLite community has been doing for a long time. And I'll give you an example. In the SQLite community, it is very common to create, because SQLite is just a file. Every time you want to create a database, it takes nothing of time. It's just to create a new file and you have a new database. People have been using SQLite for a long time to do a multi-tenancy pattern in which you have a database per user and you keep the data of every user in a different file. Again, you can do this, but in production, when you're doing this, you have things about how do I migrate the schema of all of those databases at the same time? How do I keep track of all of those databases? And Turso builds functionality to make those things easier. Another example is one addition that we made recently, to Turso. You can read more about it in turso.tech/vector. We just added, for example, vector search natively to SQLite. You don't need any extension. You just don't need anything extra. We just added a new data type that is a vector. So you can do vector search through this data type. And again, those are needs of the community that people are running production applications with. That if SQLite does it all, it will take many years. And it's usually not what they're interested in doing. They want to have like this very simple database just to push data in and out. And look, if you are building modern applications, a lot of times one of the things you do want to do is use vector search now in this new AI era. So when we say SQLite for production, that's what it means. Is that thinking in the context of your web database like Postgres and MySQL, can SQLite be used to replace or extend that, keeping the advantages of the local file? Because we can do that. We can have a remote database, and we can do replication, and we can do replication to your device on a file, so you can keep reading from the local file, but keeping now that file is a replica, and you have our master data in a central database. So you can do things like that, and you can take advantage of the patterns that SQLite has been having for the longest time through our fork, essentially.
Okay, interesting. So if I understand correctly, you basically want to keep the experience of the user when they use SQLite exactly the same.
Correct.
Keep it simple, keep it concise, but then add some enterprise level features. For example,
That's right.
replication. And replication is probably like critical, or even legally you're bound to have replicated data if you have public customers and all of that, and then backups and things like that. So it's like keeping the experience simple, like the traditional SQLite, but then extending it with these enterprise level functions or features,
That's right.
right?
And Turso is a service. So one of the things that we do is that we actually make your database accessible over HTTP. So the most natural way to use Turso is that you just create a database on our platform. The database is now accessible over HTTP, so you can query the database. You can do everything. So first of all, if you pass the URL file, you're talking to a local file, and then you keep the
Yeah.
same code. You don't change the client, don't change anything. You just change the URL from file to a remote address, and now you're talking to the Turso service. So that is the experience that we want to have. And people do this all the time. They develop locally. Sometimes people developing apps we don't even know, because they don't ping the platform, right? They're just developing on a file, like it's always been done.
Yeah.
And then when you want to push this database to a production state, you are just talking to it over HTTP, and immediately that solves the horizontal scalability issue of the application. Because one of the issues that people have with SQLite is that I have this database on a file. Now, if I have to create another server to handle more requests, the data is in that file. But now, again, all of those databases can talk over HTTP as if you were a normal network device, except with two exceptions. The first exception is that you developed everything in a file. The second, you keep the advantage that you're still doing SQLite all the way. So it's still this very simple thing that people love, just because the developer experience of SQLite is unmatched. And then there's another difference, that if you want, now I can create replicas of this database on my servers. So I create replicas that are geographically close to you if you want, or you can create a replica as a file in your server. So now you have those two servers, and they all have their own files, and the Turso service is keeping them in sync. That's what it's doing, right? Through HTTP. So you do your local reads you go back to the beginning of local reads, and you can do anything in between. You can use Turso without ever pinging our service. Just use our SDK, do your local thing, and be done with that. For example, to get vector search, you can do that. You can use exclusively HTTP, or you can use a file again. So it gives you a lot more flexibility on how you're going to interact with your database.
Interesting. Those are some interesting points, and I would also love to talk about the tenant multi-tenant support that you mentioned. Uh, but I want to kind of distinguish between two use cases. So let's say I'm a user and I have some application and I've been using SQLite, right? And I understand that moving to Turso will be easier because
Mm-hmm.
I don't have to change a lot of things in my code, and also the experience that I'm getting. For the
Mhm.
new users though, let's say I'm building something new, what is there? Like I understand there is like simplicity part to it, but what is the feature, or what is the one thing that I should look for when I choose between something like, let's say, Postgres
Mhm.
or Turso, when I have no experience, let's say, with SQLite ever.
There are a couple of things. So one of them is that there are, and we hear those are things we hear from users, especially users who came from other databases, because that does happen a lot. One of the things we hear is just that the simplicity itself is a feature, like because
Hmm.
the lack of features in a sense is a feature, because just SQLite is a much easier database to grasp and handle.
Yeah.
Databases are usually complex, so some people appreciate just that, like the SQLite just works. There's nothing for you to do, and it's just there, and there's not a lot of SQLite has 4 data types, and right, so there's not a lot of room to do things wrong. And sometimes I say because of that, it's almost like the JavaScript of databases. Is
Hmm.
this things that if you're really strict about what the state of the art of a technically excellent database should be, SQLite is not that. In the sense that compare, for example, Haskell with JavaScript. I mean, I would imagine no sane person would believe have any. There's no definition of the word better in which it would apply to JavaScript. I think for
Yeah.
SQLite there are some. Like it's just so much simpler, and that ends up winning at the end because the developers like that simplicity. So I think that lack of features is a feature, first and
Yeah.
foremost. The second thing is just the price, because SQLite is a database that has traditionally and through those 20 years been developed towards running in very low resource environments. So it's an
Hmm.
extremely efficient database. And again, it can be kept efficient because it doesn't do much, right? So you have the and so you can afford to really zone in those use cases where you don't really use a lot of resources,
Yeah.
which means we can offer extremely attractive plans for our users. And one of the things that people say a lot about Turso is that our free tier is already extremely generous because it doesn't cost us that much to run. It's just something that we do. So look, it's just that is in itself a reason why a lot of people come to Turso. And the other reasons, like we see a lot of traction. We see a lot of traction for embedded replicas because now you have an advantage that you can do microsecond level reads. And look, databases are always in this fight to see who is faster. And if I can replicate the data inside your server on the file system, like you can't get any faster than that. So there is a speed advantage to do this. The multi-tenancy aspect, that there's a lot of companies that are privacy minded. They'll say, hey, I mean, I would love to keep my customers in different databases because it's one fewer thing for me to worry about. It's just that it's not cost efficient with other services, and with Turso it is. And we have been seeing over the past couple of weeks, ever since we launched it, like a lot of interest in our AI product, like with the LLM, the 4 LLM edition of vector search.
Interesting. I think that makes a lot of sense. You mentioned one point about, so someone who is already using a SQLite database, they can simply switch to this remote service on HTTP,
Mhm.
and without changing the experience, right? Uh, but
That's right.
if I understand correctly, so saving something locally and saving something on a remote service adds a little bit of failure modes, right? So how does that work without changing the application code?
I mean, you don't have to give me an example of a failure mode that you will be concerned about. You think
Like,
about the trend, yeah.
yeah, like transient network failures, or like timeouts, or latency increase, and
Hmm.
the way we monitor things, and that itself changes, right?
Right. So look, it's not that SQLite queries are always in microseconds. Like people do expensive queries.
Yeah.
Look, the network latency will add you like at most 20 milliseconds, especially if you replicate aggressively, like we recommend.
Yeah.
You always see people talking about database queries that took a couple of seconds. So look, you have the same classes of issues for very simple applications. You're right. I mean, if you're writing something very 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 simple that just uses as a key value store and pushes like a little bit of data in and a little bit of data out, it always works, and you never have to worry about it. You're right. So you you're getting more professional, and you will now have to worry about things that you didn't have to worry before. But for the complex applications, look, the network latency is not the reason this very complex query took a long time.
Yeah.
So you probably have, usually what happens is that you have one query that is like that, and then you have a lot of queries that are not. Otherwise, there's also not a lot of advantage in replication. But you have to monitor the whole thing because of this one query that took long, and disks can fail, like servers can go down. You have all of those things. Like usually you're already monitoring your application anyhow, because your application needs to be monitored, database or no database.
Yeah.
And then you can put one more entry point there and monitor it. Look, you usually have an endpoint, and you are monitoring this endpoint, right? So you can see that the endpoint started to fail, and okay, it's failing more now. It might be because of the database. So I mean, you're technically right. Like, it does have some things that you have to worry about a little bit more, but those are not things that you would not necessarily do because you have a file. Some people would, some people would not, and there are things that are not incredibly hard, and
Yeah.
it's usually something that you're already doing for all of your other services anyway.
That is definitely a fair point. I just wanted to understand like how
Absolutely.
the thinking model or the mental model
Mhm.
changes, but it like majority of it stays the same depending on the how complex.
Also a lot of those things are handled by ORMs. A lot of people, what they would do is that they would not talk to the database directly. And
Yeah.
I'm not advocating for this to do this or not, but the reality is that you look around and lots of people will use ORMs in the TypeScript ecosystem. For example, lots of people use Prisma or Drizzle,
Hmm.
and those are ORMs that work with SQLite, but they also work with Postgres and MySQL, and they have it as a goal for you to
Yeah.
migrate between those databases easily. So they already come with all of that, right? So the ORM layer does handle a lot of that complexity for you.
Yeah. Yeah. That's a fair point. Let's talk a little bit about how the replication works. You
Mhm.
said that it's building native replication for SQLite. So what does that mean, and how does it differ from the file based replication that other
Yeah.
solutions are doing?
So one of the things that we change in the core of SQLite, because if you go look at the libSQL project, it has the core and you have the things that go around it. One of the things that change in the core is that we virtualize the wall. The wall, for those who don't know, is the write-ahead log. So every change that is made to SQLite has two modes of operation. For example, journal mode and wall mode. We do not support journal mode. Turso only works exclusively in wall mode. So in wall mode, you have the database file, and then you have a set of files that represent the write-ahead log. And SQLite manages those files. And when you read data, it could be in the write-ahead log or it could be in the B tree, and you have to look in both of those sources. That wall also has an index.
Mhm.
So you see like the wall is, as it grows, as you have more segments, this index number goes up, and it goes up linearly, and it's a very trivial, simple algorithm because it's just everything is local. Now, what we do with Turso is that we virtualize that wall and allow you to replace the wall, right? Uh, we every change that happens through the wall, we have access to those changes right away. And then there are a couple of components that are present in this equation. The first one is what we call libSQL server. So the libSQL server is the component, and all of this is open source, and all of this is part of the libSQL repository. The libSQL server is the component that makes your database accessible over HTTP and also handles backup and replication. So when you write to it over HTTP, so the writes always happen over HTTP on Turso, unless you're in develop mode fully on a file. So the production writes always go to the libSQL server that is accessible over HTTP. The server writes to the file, to the local SQLite interface, but now it has access to the write-ahead log through the fact that we virtualize the write-ahead log. So we replace essentially the code on SQLite that would handle the write-ahead log by our own. Now we get there, we say, hey, those changes happen to that database, and then I acknowledge the change and replicate to other instances of the libSQL server, potentially. So replication can happen two ways. The first way is that it goes to other instances of the libSQL server. So now I have libSQL server here in Canada, and I have libSQL server close to you in Frankfurt, which is a region that we support on Turso, for example. And I just get this package of the write-ahead log, and I ship to your replica in Frankfurt. When the replica receives the write-ahead log, so it's not logical replication at the SQL statement level, it's the whole wall. So it contains the whole transaction. If there is a transaction, everything is replicated at once. I just put that log into the file, right? This write-ahead log into the file. Now, this happens in a different format than SQLite would expect, but that's fine because we're virtualizing this and we have access to this, so we know how to read it, right? But essentially, I'm shipping those fragments of the wall to your version of the libSQL server, to your instance of the libSQL server. And the other thing I can do is that I can ship the same wall segments to your file locally. You don't need, so when you're reading, you don't need, we call that embedded replicas, you don't need the server. You can read locally because I'm shipping the wall fragments to you as well. Because of that, you can't really read, the file format is the same. So if you open the file with SQLite, you will still see everything, right? You still see absolutely like, you can still read the data. But that's why to do the synchronization, we need to run the libSQL SDK, because the libSQL SDK is the thing that receives the wall frames from the libSQL server and say, okay, now here's how I materialize that locally as a SQLite wall frame, essentially. So that's essentially how it works. And there's always one primary, so you never have issues with consistency. So our model is very simple, and we do believe that simplicity is a feature. So yes, there are some things that you cannot do with this model, but so be it, right? There are many things that I can do in my life, and so be it. I can't fly, and I made peace with that. And the consistency model is very simple because the primary is always going to serialize all the requests. The segments are all ordered, and they're passed to the replicas in order. So you just have your replica is lagging behind, but you have essentially the full consistency guarantees there. And the other thing that we do is that the replicas always read your own writes. And the way we can achieve this is that when you do a write, the libSQL server replies to you saying your write is acknowledged, which is what you would expect, right? So you write to a server, the server replies, say, okay. But together with this reply, it also tells you the replication index of the server at the moment and say, oh, your reply is on the index 32. So actually could have been 31, 30, but index 32 is what I have now, contains your write, right? So if you have anything that is more than 32, your writes are there. So when you go to a replica, every time you ask for a replica, so you read your own write. So in the same client object, you create a client object, you read something, you write something, and then when you read, you pass the replication index. Say, I want to read this thing, so route me to the closest replica or read from the local file. And by the way, my I need to read from at least replication index 32. The replica knows its replication index. And if the replication index is, for example, 30, it's going to say, I can't serve this read. It doesn't have the data that I need. And then it proxies you to the primary. So you still, by doing this, your latency can be a little bit higher right after your write, but you achieve regional write semantics, right?
Yeah, that's fantastic. I mean, it's a trade-off between latency and consistency. Like what I want, I
As
can
always,
choose.
right? But as always,
Yeah,
right? So, but the thing is that I can transparently get you to either primary or replica, depending
yeah.
on that.
Okay. How does the user know the offset though?
Because the write responds to you. The write just say, "Hey,
Okay,
I acknowledge the write,
got
and
it.
this write is present in anything equal or lower than a certain number."
Okay, that makes sense. I want to understand the topology a little bit more. So you mentioned there is this primary and replicas. So let's take an example. Let's say I have like a very simple application, for example, a to-do application, and
Mm-hmm.
I'm deployed it in multiple regions, and I have multiple servers running, and um, probably there are separate, I don't know, tenants as well.
Mhm.
um, and then how is the data partition, like how does it know
No,
that
it's always a full copy. It's all
okay,
we,
it's always a
we
full
again,
copy.
simplicity is a feature. That
Okay,
does
okay,
mean that we're not going to handle databases on the petabytes, and that's fine. That's not our niche. Go use Scylla.
okay. That
So
that
yeah,
clarifies some questions
yeah,
I had. It's like a simple cluster of my application nodes, and each of
hmm
the TursoDB instances running, and then one of them is primary, and then rest of them are replicas. And
exactly.
how is the primary decided then?
It again, simplicity is a feature. You allocate a primary in a certain location, and it's there. And
Okay. So when I create
there,
this database, I have to select like what all regions I want, and
exactly.
then one of
Yeah,
them would be primary. Probably the
exactly.
closest one would be primary, and then rest
Yep,
would be replicas. Okay, okay.
exactly.
That's nice. And next question I typically end up asking is the fault tolerance. Like, what happens if the application node goes down? Can the other replica become the primary, or that is again that you have to spin up a
Not
new?
not at the moment. That we are actually making
Okay,
changes right now that would
okay.
allow us to get to that point.
Mhm.
And ideally, we would essentially have a downtime of maybe a couple of seconds just to detect that really this primary has to be moved.
Yeah.
But what happened? But today we're not there yet. So today, what happens is that like if your primary dies, you cannot write until your primary comes back. You can still read,
Hmm.
but you can't write.
Okay. Okay. That makes sense. Um, how are these different nodes aware of the different instances of that are running of SQLite or Torso? How is that happening?
I don't think I got your question. So how are they aware of what
So how are they
versioning
aware
or?
of, yeah, like the different replicas available, like how many replicas are
They're not
running, and
aware. The replicas are not aware of how many replicas are running. They
okay,
all they
so
always
only
talk
the
to the
server
primary.
knows.
Exactly. Yeah.
Okay, got it. Okay, so again, simplicity. So
Yeah.
the
Simplicity.
primary knows everything,
The
and
primary
it
knows
knows where the
everything. Yeah.
replicas are,
hmm
and okay, that makes sense. Cool. You mentioned about the one database or per tenant database
hmm
architecture, right? Um, let's go a little bit deeper there. Like, what is the recommendation generally? Like, I understand if there is one database per tenant, you will have like a separate file stored for it. What is the
hmm
advantage of that? Is it just the performance? Is it some isolation on the transactions that we are doing,
Yeah.
or what is it?
So uh, the first one is scalability, especially with the
Hmm.
Turso model. Because when you replicate, you can think of it, for example, when you replicate those databases as embedded replicas, you don't have to replicate all of the databases. You can replicate some databases. So you can have
Yeah.
a server, for example, that handle, if you have already a topology in your application that some users are being handled by one container and some users are handled by others, you just put the databases for those users in those containers, which is, by the way, how a lot of people have been doing this pattern of database per user. the
Hmm.
the main advantage is that Turso will help you. Now you can query a container and bring it back, and Turso will just resync the databases for you, right? Through replication. But one advantage is scalability, because now you can just push this thing horizontally and isolate this in a variety of files. The other advantage is really just privacy, because now your data just does not is not mixed with somebody else's data. If some of
Hmm.
your users say, I want you to delete everything about me, you just go and delete the file. If your user says, can I download all your data about me, you handle them a SQLite file. So there are a couple of advantages of doing this. And also, for example, if you combine those things together, you can now get this one file that belongs to just this one user and replicate it all the way to their mobile device, for example, right? So you can have this capillarity of in which like data is just going into different places, and because you already pre-partitioned the data, you have a lot of technical advantages. And because the pre-partitioning of the data happen at the entity level, you can also have business advantages, like in terms of privacy and data isolation.
Interesting. Is there a recommendation from your side about when should someone think about this architecture versus a simple one, where they just have like one database
Yeah.
for every tenant?
I actually think you should always think about the simple one. Always.
Okay. Mm.
Never complicate things. Life is too short. I had a friend. You probably didn't hear my advice, but I had a friend in school. They used to say, "Life is too short to learn German." I was trying to learn it. He just said, just don't do it, man. It's just it's very complicated. Do you speak good German? Like
No,
it's so hard.
ein
Yeah,
bisschen
it's so
Deutsch.
hard. Yeah, exactly. So the same thing. Don't ever do something that is complicated.
Hmm.
And the you might just think, wow, you're just telling me not to ever use the feature, and that's not what I'm saying at all, because there are cases in which doing things multi-tenant will make your life simpler, and those are the cases where you should do it, right?
Hmm.
One of the things that people tell us a lot is that, hey, I mean, Turso is pushing this architecture. I'm not pushing this architecture. Like one of the things that I say a lot in public, and I'm taking the opportunity to say here, like Turso is a database. I give you 10,000 databases for $29 a month, but that doesn't mean you have to use them. If you use just one, the police is not coming after you. That's fine, right? So like if you want to use just a normal database, do it. And the criteria to choose, am I going for a multi-tenancy model or not, shouldn't be why do I need the complexity of multi-tenancy. It should be, do I need the simplicity of multi-tenancy? So like is using multi-tenancy making my life simpler? Now, simplicity could mean many things. Simplicity could mean technical things, or it could mean business things. So, for example, maybe you are in a regulated industry, and even though you're going to have to build a little bit more software to do this, this will make your compliance story simpler. So, overall, you're making your business simpler, but you're still pursuing this application because something in your architecture is becoming simpler. And that is what I exhort your listeners to do. Like, don't try to use this architecture just because you think it's nice. Use it because it is making your life simpler. And if you use this heuristic, then I don't need to tell you when to do it, because you look at the problem and say, hey, this problem would be simpler if I would be doing this, right? So always look for simplicity.
Okay, that makes a lot of sense, and that's also a very good mental model. Like if you keep the simplicity at your core, implementation, you'll get your answer.
Yeah.
And
That's
I
not
think
an
I think
advice, by the way, that I used to follow as a young programmer. And I think as a young programmer, if I can go a little bit deeper here, we tend to, not everybody's like that, and I think there's also a class of people that are like that, are just not ready to admit it. But you end up as a junior person, you have lots to prove.
hmm,
So you want to do lots to prove and lots to learn. So you end up seeking those complicated things to prove something to you, to others, and to some extent to hone your skills. But again, if you do this as a hobby, it's fine. If you do it in the business, sometimes you hurt the business. But you have this need to prove to you and to
yeah.
others that you're actually good, that you're impressive, that you can do things that nobody else can. Uh, Look, I've been in business for 20 years. I made peace with the fact that I'm stupid. So I go for simple.
Yeah, there's a term called RDD for these things, like
Yeah,
resume driven development.
exactly. Yeah. No, but I
Cool.
guess if you do this on your free time, it's fine, because
Yeah, for learning.
you do need to learn. But
Yeah,
when
yeah.
it comes to solving the problem, I think the sooner you realize that, look, man, just keep it simple, keep it simple always. And
Mhm.
it does mean that you have to look at yourself and say, maybe I'm not as smart as I thought I was, but that's fine.
Cool.
Mm-hmm.
You also mentioned about schema changes, and
Mm-hmm.
how Torso makes it easier to change your schema. And schema changes are like very often business requirements change, and you need to do things. How does that work with Torso?
So look, we support normal alter table statements. We don't do anything fancy in that sense. So we do a couple of things that SQLite does not allow you to do. Some things like change the type of a column and etc. that we do. So we made those changes because
Hmm.
that's things that people have been asking for.
Hmm.
But the schema change itself, we just don't do anything fancy.
Okay.
Usually, what happens is that ORMs will have their own schema migration functionality. Like, so if you look at Prisma, if you look at Drizzle, one of the things that they will do, or Atlas, for example, in the Go space, although Atlas is written in Go, but it works across any kind of database, they have their own things to do migrations. So we just rely on those tools. There is one exception to that rule. One of the things that a lot of people complain about the model of, like, hey, I would love to do multi-tenancy, because again, it is our goal to make your life simpler when using multi-tenancy, right? And we will be
Yeah.
building more and more. So we do want to lower the bar of like which use cases are made simpler by using this model. But what we heard from a lot of users when we first announced is that, yeah, multi-tenancy makes a lot of things easier for me, but it does make this one thing more complex, which is schema changes. Because now if I have to change the schema, I have to change the schema of 10,000 databases. So we went to the drawing board and figured, okay, let's solve that. And then the way we solved it is that when you create databases on Turso, you can, again, you don't have to. I want to be very explicit about that. Like, you don't have to, but you can create a database that's called the schema database. And then later you create databases that are child databases of the schema database. Or you could think of it as a parent database, or just call it schema database because that's what it's doing. When you make a schema change to the parent database, it is propagated to all of the child databases. So a couple of things in how that happens, because that sounds like magic. First of all, we guarantee that all databases at all times always have the same schema.
Mhm.
So it's not that you can bring your own database and now put this database into the set of databases in the schema. They are created as child databases, and when they are created, they already inherit the existing schema right at this moment from the schema database. So we know, right, that those things are are all the same, and we don't support this over multiple primaries. So we have a concept in Turso called a group, which is essentially things that are guaranteed to be in the same physical data center. And we don't allow, the schema change is only propagated in the same group. So you have the group. And what that means is that there's nothing network related there. It's everything local in the same server machine on our side, which means we can just go do the migration in every single one of the files. If one of them fails, we roll them all back. So we can give you this guarantee that your migrations are going to be applied. First of all, a lot of the failures in schema change, especially in SQLite that has a very lax data model, they happen because the statement itself fails. It's not because of anything in the data. So that will already fail on the schema database when you try to migrate the schema on the schema database. But then you have failures that can happen if the data is sometimes, right, if you're adding constraint or something. But then what we do is that we just roll back everything that happened in those databases.
Okay, that makes sense. I'm trying to relate it with this idea of keeping the data and metadata separate. So
Mm-hmm.
is it the same model, like where you have this schema, which is like the metadata for all the data or all
Mm-hmm.
the per tenant databases that you have, and then you know this relation. So in each file, mainly the data, but actually the
Mm-hmm.
schema is in at the parent level. Does that
Well,
make
no, the
sense?
schema is because remember, each database is still a SQLite file, so the schema is
Hmm.
also in the database. The,
Okay.
the thing that we're doing is that we're making sure that modifications to the schema are being propagated
Okay.
to the database files. Right?
Okay. That makes
And
sense.
the way to keep it simple is to keep it local. So we allow this. You create a group on Turso, and that group is again a set of databases that will be in the same location, and then you essentially apply schema changes through this group.
Okay. That makes sense. How are these schema changes replicated? Again, the same way, or?
Same way, because the schema changes on SQLite are just things that end up on the wall. So
Yeah,
you just ship the wall and.
perfect. Cool. Let's talk a bit about vector search. Since you mentioned
Hmm?
there is also that capability. What exactly did you change to add that functionality in SQLite?
Well, I didn't change anything. Becca did.
Yeah.
In fact, I did change a couple of things. I wrote C after many years, so that was a cool experience. I've been more like especially after founding the company, I've been writing less and less code and more managing the company, right? So it was a good experience. So there were a couple of things. We changed the grammar a little bit. So SQLite has a very lax data type. So you can go right now and create a table with a type that you just made up. You can do that, right? That means nothing because SQLite is the JavaScript of databases. So the type is essentially a hint. So when you create a table, we asked you to use a specific type. It's a hint, and then SQLite has something called type affinity. So if you define something as an integer, SQLite will assume that when in doubt, what I'm seeing here is an integer, but you can essentially write everything you want in there, right? So vector is the same thing. You define this is a float 32 or Boolean for if you want to do like binary quantization, stuff like that. This is still in development, the Boolean thing, but you define this type as float 32 with a number of dimensions, like 45 dimensions, right? Or 512 or however many dimensions you want your vector to have. This is a hint, as you know, as well. Essentially, it is represented internally as a SQLite blob. So we wrote code to the grammar to allow you to create the index using that as a hint. So when you create an index using vector search, we create an index using an algorithm called disk ANN. For ANN stands for approximate nearest neighbors. And the index will look at this definition of the table and say, oh, this vector is a vector floats with 512 dimensions. Here's the index. And then there's a couple of changes to the SQLite bytecode executor to make use of those things. I myself don't know all of the details, but like SQLite, essentially what it does is that it generates a program, a bytecode program that executes your query. We made a couple of changes to those opcodes to be able to use things like order by and limit and etc. So you can do all of the things that you would do normally on your vector search. And the index itself is done by allocating SQLite pages. So those pages get replicated as well when you do replication.
Okay. Sounds simple enough. I mean, strategy wise.
It's not rocket. I mean, it's good, but it's not rocket science.
Yeah. Similarly, do you also have plans to add some OLAP style queries and no, nothing?
No, not in the short term.
Full text search.
Which should be full text search exists. SQLite has a full text search already extension that we compile natively. So if you deploy a Turso database or use a Turso SDK, you will have full text search on by default.
Okay, perfect. I guess you probably talked a bit about what's in the future, but what's in your roadmap? Like, what are your release plans? What are other features you're working on?
We are working, for example, like you just asked me about one, the ability to move primaries. So that is one of the things that we're working on. And together with this ability to move primaries, the ability to automatically move primaries in case, for example, your primary dies. So we don't want to have downtime. We do find that the idea, especially with modern networks, the idea of like I can't write for the database for a couple of minutes, maybe is acceptable because a lot of the use cases that come to us are read mostly. Almost SQLite excels at reads. SQLite is actually not that great for writes in comparison with other databases. So you already have this filter of people. But we do want to have that, and this is something that we're working on. And the other major thing that we want to work on is I mentioned to you that every write goes to the primary. So the writes always go primary first, and then they're replicated back to you. When you have, for example, a copy of the database on your own server, when you have a copy of the database on your mobile, those things the writes are always server first. We are trying to work on a model in which the writes are also local, and then your primary now is actually doesn't even become. It's not even fair to call it the primary anymore. Like your remote server now is the replica, and it can also serve as a distribution point for other replicas. But one of your servers or your mobile device, etc., is the writer. So you could use this, for example, to do offline writes. So if you are on a mobile phone, your user is making updates to the application. But when they come online again, this is replicated back to the remote server, and it can go to other replicas. But change those things are actually quite similar in scope. There is a lot we map the work needed to do those things, and a lot of that is in common, because it's the ability to make it a little bit more flexible. Who is the primary, right? Keeping the simplicity that we want to keep.
Interesting. Well, looking forward to all the amazing features. Thanks a lot for joining me today. It was really wonderful
It'll be my
talking to
pleasure,
you.
man. My
Thanks
pleasure.
for sharing all the stories, experiences, humor, and insights into Turso. And yeah, all the best to your team and yourself for the future releases.
Thank you.